start the class. If the voice is not clear, then only you switch off your videos. Otherwise, keep the videos on. Okay, no problem. Depends on your internet connection. Fine. Okay. So I'll just share the screen. Now you will see. So you see one more screen I have shared. Can you see I have put the syllabus for you all? Okay. So in this 9th sem, you have again first paper is your inorganic paper. Okay. And I think you have already started some chapters in this. You have started MOT, I think, second chapter as well as the third chapter, right? So after your symmetry, you have already studied about your free ion terms in your last sem, right? So after that, we study this part, that is the group theory. Then comes its application, that is electronic spectroscopy. Okay, so it is like if you are so first you have to study about the symmetry. Okay, symmetry tarvata next chapter you have to study is the free ion terms. Who taught you free ion terms? Free ion terms of the metal. This is an interaction class. Please unmute yourselves and please tell me. Yes, Divya? Jaya? Rajeshwari?
Yes, ma'am.
Yeah. Who taught you free ion terms?
Yamini, ma'am.
Yamini. Okay. Here you have learned how to find out which term is what are the terms, what are the microstates, right? How are they arranged? All that you have studied in this, right? So first basics you are going to study about the symmetry in the molecule. Second, you will just see how to write the energy levels notation, ion terms, what is the terminology. Okay. Then third one is you are going to club this symmetry with that of the mathematics. Okay, and then you study the group theory. Okay. Now using all these three, you have to apply. That will be your fourth chapter, that is spectroscopy, electronic spectroscopy. Okay. So what is that you are doing? So all these three things become basic for this electronic spectroscopy. Okay. Electronic spectroscopy. So when you are looking at the syllabus, you already studied the first two chapters. Okay. Then the third chapter I am going to teach you, that is group theory, normal mode analysis and spectral activity. Then comes the application part, that is you have already started. So we'll rush a little bit so that you catch up the fundamentals in the electronic spectroscopy. Okay. So in this you have to study, what is that you have to study is, these are the syllabus, this is the syllabus. Please recheck again. If any changes are there in your new syllabus, let me know. Okay. So when you come to the syllabus, this is a very big chapter, and just like symmetry, you should keep on doing them. Okay. So when you start with little bit of mathematics in this. Okay, so you have to study about the group multiplication tables. Okay, properties of a group. Again, in that you have subgroups, you have classes, then how to represent the symmetry elements with the help of matrices, block factorization, matrix representation of these elements, symmetry elements E, Cn, Sn, I, and sigma. Then matrix representation of C2, C3, C2v, C3v, and C2h point groups. So first we are doing for the elements, then we are doing sorry, for the point groups. Then how to write a character of a matrix using these representations, reducible and irreducible representations. Okay. Properties of irreducible representation, how to construct a character table for the simple point groups like C2v, C3v, and C2h. What is the Mulliken symbolism for this irreducible representations? Standard reduction formula and direct products. Okay. This itself is a very big chapter. Then comes the little bit of application. That's what are the normal mode analysis and what is the spectral activity. Okay. So this is your syllabus. So before going into the syllabus, to start, I'll just brush up with that of the little bit of the symmetry whole chapter. Okay. So I'll be asking you questions. You just tell me whatever you remember. I know it's almost 1 year. We have learned symmetry, but you are not supposed to forget symmetry, right? So any molecule you see, you should be able to tell the symmetry. Okay. Okay. So I'll just start with the chapter. Can you tell me what are all the symmetry elements you have seen? Yeah, Rajeshwari. I'm trying to open one more. You can talk, yeah? Yeah, Rajeshwari.
Yes,
Tell
ma'am.
me, yeah, what are all the symmetry elements you have studied? How many types of symmetry elements are there? Symmetry operations are there? Point groups are there? Anything you can answer. Or can you tell water belongs to which point group? I think this is the easiest question.
Yes, ma'am.
Yeah, tell me. Water belongs
C2V.
to water belongs to which point group?
C2V.
C2. So what are all the other point groups that are present?
C3V, C4V, C2H, and D2, D2V, D2D, D2H,
Hmm. So you know all these
C.
point groups, right? We have studied many examples last year, and we have studied these symmetry or the point groups in the what do you say, in all most of the molecules. Okay, so we were able to assign, when you look at the molecule, what is the symmetry. We are not able to see the screen which I have shared. Okay. Can you see the screen now? New screen. So are you able to see this new screen? I think you can see because I am connected myself also, so that okay. So your syllabus tells that you are supposed to study about the group theory. What this group theory exactly means. Okay. So group theory is nothing but you have to study about the uh, so whenever you are linking this molecular symmetry to that of some of the mathematics, okay, so you call it as a group theory, which is a branch of mathematics. So when you combine this little bit of mathematics and little bit of molecular symmetry of the molecules, you can study so many things. Okay, they help in studying all these things. What is this? Some quantum mechanical equations you can study. You can explain hybridization theory. You can explain some chemical reactions, find the wave functions. You can study this electronic spectroscopy. You can study the John-Taylor theorem. You can study the catalysis. Then you can predict theoretically, you can predict the molecular geometry, dipole moment, optical activity. You can reason out the ligand field theory as well as many other chemical applications. Okay, so you are combining the symmetry, whatever you know for that particular molecule, and you are applying a little bit of group theory, that is a nothing but a branch of mathematics. Okay, then you are able to apply those two to find out or to interrogate all these applications. Okay, so we will see what this means. Before going into that, so a group is nothing but, just to have a definition, okay, a group is nothing but it is a set or collection of elements, okay, set or collection of elements which are combined with the operation. Okay, so whenever a group, whenever a element is combined with the operation, then that group should have an identity. Okay, that group can have inverses, that operation is associative, and the group is closed under the operation. We will see what these are. So whenever I'm telling it is a group, it should follow certain mathematical entities, like the basic properties is it should follow some 4 rules, that is the closure rule. Okay, then comes the inverse rule, then comes the identity rule, okay, then comes the associative rule. So these are the 4 rules which it has to follow. So we will see what these 4 rules are. Okay, so if I am talking about a group, okay, let that group have these elements. Okay, suppose if I am telling C2V is a point group, what are all the elements in that C2V point group? Can you tell me? Yeah, C2V point group. What are all the elements in C2V point group? So if I take C2V, okay, so what are all the point groups I have in that? This is a point group. What are all the elements? Identity is there, right? Is it a problem to unmute yourselves? Okay. Then you have C2. Okay. Then you have a sigma V vertical plane in the XY, or sorry, XZ, and one more you have in the whole molecular plane. I can tell the YZ. Okay, so you have, or I can simply put sigma and sigma prime. Okay, so 2 vertical planes you have. Okay, so these are the 4 elements present in this particular point group, that is C2V. So how many elements are there? 1, 2, 3, 4. Okay, and how many operations are there? Operations means the movement. Okay, the operations are also 4. So in this particular point group, there are 4 elements as well as 4 operations. So there. So if you take any group, so instead of telling C to B, I will tell that it is having the A, B, C, D, E up to X. These are the elements in that group. Okay. Then you should see that it should have some, it should follow some rules. Okay. The first one I can tell that it should follow the rule of identity. Identity means if I multiply with anything, okay, if I combine or if I multiply, then the element should be unchanged. Okay, so whenever I do any combination or a multiplication, it should be unchanged. So this element, what I can do is I can take the identity element. So when I take this identity element, okay, that is E, and if I multiply with A is one of the element in that point group. Okay, so if I multiply A with E, always I get A. So this element is not changed. Okay, so such thing is should be present in the group. Okay, so if I am having E in this, so if I multiply A with E, I should get A only. Similarly, if I multiply this identity element E with B element, again I should get B. So C element, again I should get C. With D, if I multiply, I should get D. Okay. So this is nothing but here. So it should have a identity. Okay. That means there should not be any change in the multiplication whenever I do any combination. Okay. So this combination, even if I reverse it, okay, even then it should not become a problem. So instead of A into E, if I do E into A, again the answer is A. Here also it is A, here also it is A. We will take an example and discuss this. Okay. First just understand what I am telling. So this is a property of identity. Okay. So this should be present. That means always there should be a element, identity element with which if I multiply or if I combine, the other element with which I am combining, that should remain unchanged. Okay, without any change. Okay. Second one is inverse. Okay, or commutative property. This is inverse rule. Okay, this is inverse. Okay. So in this you just see if there are two elements A and X. Okay, and A is inverse to X. Okay, so what should happen if I multiply A into X, or if I combine A and X elements, that should be equal to the X into A, and both should result in a identity. Okay, so where X is the inverse of A and A is the inverse of X, so I can represent as A is equal to inverse of X and X is nothing but inverse of A. So A into A inverse, so if I can put A, X is nothing but A inverse. So if I put these two also, I will have the same identity, that is E. Okay, so this is the inverse rule. So first one is it was the identity rule. Okay, second one is the inverse rule. Okay, third one, just you see, it is known as associative rule. Okay, now this associative rule, if you take this associative rule, what is that I am telling? It is having the elements A, B, C, D up to X, so on and so forth. So if I do any association, that is, I do B and C first, okay, then I do A multiplication, okay, or if I do A and B first, then I do C multiplication, or if I do A into B into C, everything should be same. So whichever way I do the combination, okay, but I should not change it, I should not come the reverse way, that is C into B, B into A. I should follow the same rule, but the way I am associating it can be different. So I am doing BC first, then A, then AB, then C. Okay, so these two first combination I can do, these two combination I can do, or without any combination, if I multiply also, I should result in the same structure. Okay, so that is known as the associative rule. Okay, then the next one is the closure rule. Okay, the closure rule is, if suppose in a group I'm having again the same elements A, B, C, D. So if I multiply A into B, I can get one of the element, I can get a C or a D or whatever it is. But should that element should be a part of this group. Okay, that means we are closing into that group. So you call it as the closure. Okay, So in this group, it can be A, B, C, or D. Okay, so these type of combinations, that is AB equal to C. So C is a part of the group. AC equal to D. D is a part of the group. BC equal to another element, which is again a part of the group. Okay, then you tell it is a closure. Okay, and you can have this closure can be two ways. That means it can be commutative as well as it can be non-commutative. So what do you mean by commutative? Commutative means if AB is equal to BA, okay, if I just reverse it, A into B is equal to B into A, then you tell it is commutative. Okay. Non-commutative means AB is not equal to BA, but it is equal to some other element. Like AB is equal to C, BA will be equal to D. We don't know. Okay. So, but those two elements should be a part of the group. Okay. So this closure rule can be of two types. Okay. So it can involve both commutative as well as the non-commutative. Okay. So we will just take an example. That is, I will take the example of the water molecule. Okay. Then you will understand and apply this rule. Now we will see. Take the example of the water molecule. Okay. And the total symmetry elements in it are 4. Okay. As well as the operations are also 4. Okay. So the order of this point group is 4. Now take this example. You can see here clearly. So I have oxygen. We have the 2 hydrogen atoms, H1 and H2. Okay. Now what are the symmetry elements in this? I have a C2 axis. Okay. So which we are rotating clockwise. Okay. Then I have a molecular plane which is in the YZ plane. Okay. Then one more I have one more vertical plane, that is sigma xz. Okay. One more plane, reflection plane, that is in the x and z directions. Okay. So these are the 3 elements, plus always you have an identity in that particular thing. Okay. So now we have E, we have sigma xz, sigma yz, and a C2 axis. These are the 4 elements of the C2B point group. Okay. Now if I take the I'll just take the whiteboard. So if I take the water molecule, so if this is the water molecule, we have H1. Girls, just switch off and come rejoin again because we are losing the time here. Okay.